Hello and welcome to our lesson on atomic number and atomic mass. So let's move on to the build part of our lesson. This is where I am teaching you new information. So last week we looked at the idea that there are different types of atoms and they are different sizes. There are about 100 different types of atoms in the world. We've got to about 116, though scientists do keep inventing and discovering a few more. And each different type of atom is called an element. And we can find a list of those elements on the periodic table. Now, you'll have all seen the periodic table before, and you'll have probably noticed there are lots of different numbers on that periodic table. Today's lesson is about understanding those different numbers. So if we zoom into the periodic table, you will see lots of boxes like this. They might look like this, or they might look like this. But you'll notice they always have the name lithium, they always have the symbol Li, and they always have two numbers. The smaller number you'll notice for lithium is always the same, it's always 3, and the larger number, well, it should be the same, but in this example they've not rounded it up, and in this example they've not rounded it up. If we rounded up those two numbers, we'd get to 7. We'll come back to that in a minute. So let's look at this one here. This is what you're likely to see in class, your periodic table that we will give you when we get back. And I've also included an atomic structure diagram so you can see the inside of the atom as well. So what do these two numbers actually mean? Well, this first number is known as the atomic number. You need to know that, so you need to write it down. This is always the smallest number. Wherever it is in that box, top, bottom, left or right, the smaller number is always the atomic number. Now you need to know what the atomic number actually means. What does it tell you? The atomic number is the number of protons in the atom. Write it down. Atomic number is the number of protons in the atom. And if I look at the diagram there, in this example, the protons are the orange positives. I can see 1, 2, 3, and that is the same as the smaller number, 3 protons. Okay, for this section, developing understanding, we're going to take what I've just taught you and see if you can apply it to the question. Pause the video and have a go at the two questions. What is the atomic number of oxygen, sodium and aluminium? And how many protons does oxygen, sodium and aluminium have? Have a go. Okay, well I really hope you've given that a go, guys. It's really important that you test yourself as you go. Make sure you've understood what I'm teaching you. So let's have a look at oxygen. The atomic number is the smaller number, and therefore I know the atomic number is 8. So I must have 8 protons because the atomic number tells me how many protons I have. Sodium, I'm looking at the smaller number here. My atomic number is 11. And this tells me I have 11 protons. For aluminium, my small number is here. My atomic number is 13. And that must mean I have 13 protons. Did you get it right? So we're back to build now. We're looking at new information that we've not learned before. And we're going to look at that bigger number. Now the first thing I'm going to do with that bigger number is I'm going to round it up to make my life easier in a few minutes. So 6.941, 6.9, I'm going to round that up to 7. The bigger number is the relative atomic mass. It's called relative because if you remember, these atoms are extremely small and we're not measuring them in grams or milligrams. So we're just saying, well, compared to another atom, it has a mass of 7. Okay, that's what that relative word means. It's sometimes called the RAM, the RAM of an atom, relative atomic mass. And sometimes you will also see this symbol here, where the little r in italics is relative and the capital A is atom, relative atomic mass. Now last week we looked at the subatomic particles and the mass of the subatomic particles, and we said that protons and neutrons had the same mass as each other, didn't they? They had a relative mass of 1 each. And we also said the electrons were so small they had hardly any mass. So when we come to calculate the mass of an atom, we are simply adding up the mass of the protons and the neutrons and not the electrons. So basically electrons are so teeny tiny we ignore them, and we're just left with the mass of the protons and the mass of the neutrons. So the definition that you need to know and you need to write down of atomic mass or relative atomic mass is the total number of protons and neutrons in the atom. I'm simply adding them up. So for example, if I look at this atomic structure, I'm saying, well, I'm going to ignore those electrons. I've got 3 protons. Those are the orange ones, 1, 2, 3. I've got 4 neutrons, those pale blue ones, 1, 2, 3, 4. So 3 plus 4, I've got a mass of 7. So whilst a lot of questions may simply ask, what is the mass of lithium? And you can look at that big number, 6.941, or you could round it up to 7. Some questions will ask you how many neutrons does a lithium atom have? And this is where it gets a little bit more complicated, and those definitions come in really, really handy. You know that neither of those numbers, not the 3 and not the 7, they do not tell you the number of neutrons. But you should know that the mass is the number of protons added to the number of neutrons. Do I know the mass? Yes, 7. Do I know the number of protons? Yes, 3, the top number, the smaller number. And therefore, I can calculate that 7, the total mass of 7, is 3 plus something. So 3 plus what equals 7? What's that missing number? We should recognise it's 4. And so I must have 4 neutrons. And so you can find out the number of neutrons by using the mass number and by using the atomic number. Okay, so we're going to develop our understanding again. We are going to test the knowledge I've just taught you. This is slightly harder, so do pay attention, especially to question 2. So first of all, what is the atomic mass of oxygen, sodium and aluminium? And then, how many neutrons does the oxygen have? Pause the video please and have a go. Okay, so hopefully you've had a go. Let's see if you're correct. So question 1, what was the atomic mass of oxygen? So the relative is this number here, the relative atomic mass. You could have said 15.999, or you could have rounded it up to 16. The relative atomic mass of sodium, that bigger number there, is either going to be 22.99, or you've rounded it up to 23. Either number is correct. For aluminium, the larger number is down here, the relative atomic mass, and your answer is either going to be 26.9815, or you're going to round that up to 27. Okay, this was a slightly more challenging question. I am looking for neutrons. I know I'm going to have to look at this mass number here at the bottom. I know that I'm going to round it up to 16 to make my life a lot easier. And I know that mass is the number of protons added to the number of neutrons. I know I have a total mass of 16, and I know I have 8 protons. And therefore my missing number, 8 plus 8, gives me a mass of 16, and therefore I must have 8 neutrons. That question, that type of question, takes a while to get your heads around, so just make sure you've understood how we've got the answer to oxygen there. Okay, so let's try to transfer some of that knowledge to an exam question. Pause the video and have a go for yourself, please. Okay, so question 1, what is meant by relative atomic mass? Now there's only one mark here, and what they're looking for is protons and neutrons. So whatever you would write, that's what they're looking for. What 2 things can we work out from the atomic number of an element? Well, the atomic number is the proton number, but in any atom there is always the same number of electrons, so you'd also be able to find out the number of electrons. Okay, pause the video and have a look at this question for me, please. Okay, so it gives you some information. It tells us that the mass number is 23, and it tells us the atomic number is 11. Okay, and it says how many protons and how many neutrons are in this atom. Okay, so number of protons, which of these numbers represents protons? Well, it's the atomic number, isn't it? And so there are 11 protons. What about the number of neutrons? Well, neither of those represent neutrons, but I can figure it out because the mass number, the bigger number, 23, take away the atomic number, the 11, gives us 12, which is the number of neutrons. Okay, that's it for this lesson, guys. I'll see you next time. Bye.